Hey people, so today we're going to start our perhaps first video on 3D graphing in Desmos, because 3D is always fun. So start off with, we need to know some basic lore, so how exactly we're going to create the illusion of 3D on a 2D surface. And well, to do that we're going to start with a sort of 2D model of what's going to be our 3D sort of system. So we're just going to look at depth and like width or height at this one time. Doesn't really matter which one you think of it as, but yeah, so we'll start with a polygon. We'll say 0, 0 is like the focal point. We'll make 3, 4 like the... Actually, we'll make it 4, 3. We'll make it 4, 3. 4, 3 is like the... There's a point. That's weird. That we're like looking at, and then we'll just go with 4, 0, and like we have like a triangle, right? And it all like has to do with like triangles, right? So if we have like a frame, which is like our 2D frame that we're looking at, say that's x equals 1, then what we want to know is at what point does this triangle intersect the frame here to then graph it on our 2D frame. And yeah, that's basically it. So if we convert this diagonal sides to like, that of like just a nice little line, we can do simultaneous equations, so we get y equals 3 on 4 in this case, right? And that's where you graph it like in the thingo. So that's just the basic law, I suppose. So let's actually create that system now. So we'll start off with our focal depth. So this just refers to like how far away from like z value 0, z just being our depth, is like our frame. I'll probably make it frame depth, to be honest. I always make it focal depth, but I think I'll make it frame depth for this time. Frame depth, just make it 1, but we can make it so we can scale it if we want, which just like zooms it in or something. I'm not too sure like what you'd call it in optics. Anyway, so yeah, frame depth, and then we'll make it so plot will be our function. So the 3 inputs will be x, y, and z. Those will just be the obviously, yep, left to right, up and down, and like back and forth in that order. Yep. So, right, we're gonna have x, y, which is just gonna be like on our 2D plane, but referring to like the like triangles, we're going to scale it by basically the frame, like the ratio of like depth frame to like the z value. And in theory, that should be it. So if we plot in some points, let's say, we'll go with 10, 10, 10, and we'll just use lists, I suppose, to, get it going. So we'll go with 10 there, 10 there, 10 there. We'll make that 20. Actually, no, we'll go 15. 10, 15, 15, 15 again here, and a 10 there, and now we have a square. We'll copy that over. Honestly, this z value didn't need like a list, but hey, there's a list, so it's cool, I guess. And we have a cube, although it looks kind of weird because I like scaling and stuff, so I think it's probably too close to the camera, I believe. Again, I'm not entirely sure how all this stuff works. I've just sort of like come across like this whole like triangle scaling idea and been like, hey, it kind of works. I mean, so yeah, if we make it way further away from the camera by changing the z value, or like the depth value, the cube looks a bit more right. And I mean, you can also connect the points if you want. So in theory, if I just make that A and then like polygon A, will that work? It does. It does. That's nice. Make that B, polygon B, and that also works. And you can connect the points on these sides here, but like to get those all lining up is like kind of effort, so you know I'm not gonna try and do that now. But you know, the point is you can connect points. You can also connect points, you know, using parametrics, which is lovely because it means you can do so many different things, really nice and conveniently as well. So let's connect like our diagonal points. So we'll go with like 10, 10, 10. We'll make this one C, and then we'll make D is equal to plot 20. Hang on, wait, no. Also, hang on, no, that's going to be 50. 50. So we'll go 20, 15, 15, 55. And these are 2 points. And yeah, the smaller square is the further away one. So now we can use our classic, I think I've shown this before, like vector method thing, which does that, connects 2 points. And because the 2 points are like on a 2D surface, you just connect them like a 2D vector type thing there. So yeah, and you have that. So yeah, I think that's a good first 3D graphics video. Might do more. You can do quite a lot with it. For example, I've got like this one here, which is kind of laggy. I use like the complex number rule of like multiplying the complex numbers to like spin it, so that's a cool application of complex numbers. And then I use the actions system, which is kind of new in Desmos, to make it so the ball rolls around kinda, but I don't think the physics on that are too like precise or like reliable or accurate, but you know, it looks like it's rolling, and when it hits the edge it sort of goes back to like one of the middle axes. So yeah, a lot of application for 3D graphing. It's all pretty simple, and yeah, that's about it. So thank you.